Let's look at OpenStax Chapter 5, Problem 29. During a circus act, one performer swings upside down, hanging from a trapeze, holding another, also upside down, performer by the legs. If the upward force on the lower performer is 3 times her weight, how much do the bones, the femurs, in her upper legs stretch? You may assume each is equivalent to a uniform rod of 35 centimeters long and 1.8 centimeters in radius. Her mass is 60 kilograms. So let's write down the things that we know and we don't know, and add things to the diagram and then solve for the problem. So we know that the length of her femurs are 35 centimeters. We know that the radius is 1.8 centimeters, and her mass is 60 kilograms. Then one thing that we're not told but we can find in a table somewhere is the Young's modulus for a bone that is stretching. So Y is 16 times 10 to the 9th newtons per meter squared. Then we also know that as she swings, the net force acting on her femurs is 3 times the weight. So F net is 3 times her weight, but that is distributed over 2 legs, 2 femurs. So F for one of the femurs would be 3W divided by 2. What we're looking for is the amount that the leg stretched. And let's figure that out. So I have my cheat sheet on the right here, and I know that there is a force, I called this just F1, acting on the bone to stretch it. We know that this was length L naught. We know that the radius in there was lowercase r, and we want to know how much this bone stretched. So starting with the formula, F is Y delta L over L naught times the area. I'm looking for delta L. So delta L will be F L naught divided by Y times A. So F is really F1, which is 3 times the weight, that's mg divided by 2. L naught is a quantity that is given. I'll have to convert it into meters. Y is also a quantity that's given, and the cross-sectional area of the bone is the area of a circle. So that's pi r squared. So now we start putting the numbers in. So we have 3/2 times mg. Mass is 60 kilograms, and g is 9.8. Then L naught is 35 centimeters, so that is 35.0 times 10 to the negative 2 meters, divided by Young's modulus, 16 times 10 to the 9th newtons per meter squared, times pi times the radius squared. So the radius is 1.8 times 10 to the negative 2 meters, quantity squared. And when we plug these numbers into our calculators, we end up with 1.9 times 10 to the negative 5 meters. Or if we convert it back into centimeters, it's 1.9 times 10 to the negative 3 centimeters. So this is how much each of her femurs stretch. A very tiny amount, but there is a significant stretch.